Another way to find the inverse of a 2 by 2 matrix uses determinants. If matrix A has the first row AB and second row CD, then the inverse of matrix A is equal to 1 over the determinant of matrix A times D, negative B in the first row, the opposite of C and A in the second row. What would have to be true about the determinant for the matrix to not have an inverse? If you look at this expression, what could cause it to be undefined? Since dividing by 0 is undefined, a matrix will not have an inverse if the determinant, see, that's here in the denominator, is 0. In this case, the inverse does not exist. If you're using WebAssign, you would have to type D and E on those problems. So for example 2, we're going to find the inverse of matrix A with a first row of 3, negative 1, and a second row of negative 2, 2. Our first step, we're going to find the determinant of the matrix. So multiply our first row, our first diagonal, 3 times 2, minus multiply our second diagonal, negative 1 times negative 2. 3 times 2 is 6, negative 1 times negative 2 is 2, and 6 minus 2 gives us the determinant of matrix A is 4. For our second step, we're going to switch the terms in the first diagonal of the matrix, switch the signs of the terms in the second diagonal, and then multiply each term in that new matrix by the reciprocal of the determinant. So the inverse of matrix A equals 1 over our determinant 4. Okay, our new matrix, we've switched this first diagonal, so now we have 2 here and 3 here. And for our second diagonals, we've changed the sign, so our negatives turned into positives. If they were positive, we'd make them negative. And now we're just going to distribute. 1/4 times 2, a fourth of 2 is 2/4, which is the same as 1/2. A fourth times 1 is 1/4. A fourth times 2 is 1/2. And 1/4 times 3 is 3/4. So here's our inverse.